This is Afia Adebola Johnson, your biology and chemistry tutor. Yes, we want to look at another area of titration again, which has to do with determination of percentage purity and percentage impurity, revolving around Na2CO3 that we want to use in the NECO practical of 2024 this particular year. You have a question on the board. A is a solution of 0.038 mole per dm cube. Per dm cube H2SO4. H2SO4. Full stop. Then B is a solution of impure Na2CO3 containing 3 grams of the impure salt per 250 cm cube. Then you also put A into the burette and titrate it against 20 cm cube or 25 cm cube portion of B using methyl orange as indicator. Repeat the titration process for 2 or 3 more times until a concordant titer value is obtained. You are given the equation and you are given some numbers here for your calculations. So let us titrate now. So I will be giving 2 beakers. Then I will wash out for the one they label A. The instructions say I should put that A inside the burette, and this is the burette. I will fill it until it gets to 0. Yes. Then the next one is to titrate this against 25 cm cube of B. This is B. So I have it here. Then I put 2 or 3 drops of methyl orange in B. Then the solution has turned yellow. Then I titrate. Yes, the color has changed. Yes, and I have 3.4. So now when you are writing your table, first thing is to write size of pipette 25.00 cm cube, because they ask you to titrate against either 20 or 25. But your pipette is 25 mil that they write here. 25 mil. So because of that 25 mil, the size of my pipette is 25.00 cm. It then means that what I pipetted inside here is 25 cm cube of what? Of B. So I'm going to write here, because I fill this thing to this place, I will put initial reading is 0.00. Now I have 3.40. That's my final reading. If I take this away from here, I have 3.40. I want to fill it again, 0.00. So fill it again. So I'm putting 0.00 because I'm filling it again. Let me use my funnel. Filling it to 0. So let me take B. I drop it here. So the next thing to do, to put meteorate, 2 drops or 3 drops, the solution has turned yellow, then I come to titrate. Yes, the color has changed now. So what I have now is 3.123, 3.3, 3.30. Take this away from here, you have 3.30. You will see that the difference between 3.40 and 3.30 is 0.1. So the difference should be between the rate of 0 or 0.1 or 0.2, plus or minus. Then I'm filling it again to 0.00. So if I titrate again, let's assume I get 3.30 or 3.40. 3.40. So then average volume of AUs will now be, I don't need my rough, so I can take this and this, 3.30 plus 3.40 divided by 2. So I will have 6.4567, 6.70 cm, over 2. So that should give me 3.35 cm. Please, the SI unit is as good as the answer. The SI unit will score and the answer will score. Don't forget that. Then go back to the question in per se. From your results and the information provided, find concentration of B in mole per dm³. Yeah. What do they say about B? B is a solution of impure Na2CO3. Impure, the cause of this adjective impure. Whatever number that is given here, 3 grams, we cannot use it for the concentration because of this adjective impure. So we are going to assume that Na2CO3 does not have any concentration because it is impure. So we want to look for the concentration of the pure one. Concentration of pure one. And to do that, since we know the concentration of A in mole per dm³, we use CA, VA over CB, VB equals to NA over NB. What is my CA? CB is concentration of A, which is given. A is a solution of 0.038 times VA is your average tracker value, which is 3.35. Then over CB that we don't know, times VB is the size of the pipette, which is the volume of the vase, which is 25.00, equals our NA. Go to the equation, you can get that. The question says A is a solution of 0.038 mole per dm³ H2SO4. So in the equation, A is H2SO4. So what did they use to balance A? Nothing. It means there's an invisible 1. So our Na is 1 over. Then the question says B is a solution of impure Na2CO3. So here, Na2CO3 is balanced by 1 also, and our NB is also what? 1. So we are done. So what we do now is to cross multiply and divide both sides by 25. So our CB will now be 0.038 times 3.35 now divided by 25. So CB, this is mathematics now, not chemistry any longer. So now, so what I have here is 0.005, 5 mole per dm³. So that is the concentration of B in mole per dm³. Then the second question says they don't want it in mole per dm³ again, they will now want it in gram per dm³. Don't forget the formula to do that is what? Molarity. Molarity equals to mass concentration, mass conc over what? Molar mass. So the molarity that we got before is 0.005. The mass concentration is what we are looking for now, mass conc over the molar mass of B. B is Na2CO3. We are given that Na, we are including it here, Na is 23.0. Please take note. And how many NA do I have here? I have 2 of them. So 23 times 2 plus C. And C is what here? 12. Plus, next one is what? O. And O is what? 16. And how many 16? How many O do we have? 3. So, we now have 0.005 is equal to mass concentration. If you do this very well, you get 106. Now, having done that, we can now cross multiply. Our mass concentration will now be equal to 0.005 times 106, cross multiplying. So our mass concentration will now be equal to, now that's 0.53. 0.53. Now, gram per dm cube. 0.53 gram per dm cube. Now, then the next one, percentage purity. Don't forget, the formula for percentage purity is equal to mass of pure salt over mass of impure salt. So let me use substance. Times 100 over 1. So we have percentage purity now. What is the mass of the pure that we just got? That is 0.10. Before that, we need to know we are giving certain mass, but the dissolve in 250, we have to standardize it first to get the mass of the impure in gram per dm cube. So now what do? We have 3 grams of Na2CO3 dissolved in 250 cm3. Now, according to this question, 3 grams of the impure salt per 250. But a standard solution, in a standard solution, the concentration must contain amount dissolved in 1000 cm3, not amount dissolved in 250 cm3. So we are looking for the mass, which we don't know, we represent by X. X gram of Na2CO3 that will dissolve in 1000 cm3, not the one that will dissolve in 5 and 250. So we now have 3 over X is equal to 250 over 1000. 250 here 1, 250 here is 4. So we have 3 over X equals to 1 over 4. Our X will now be 3 times 4. Answer is 12 grams per dm. Now, if that is taken, we can now say, okay, now, our percentage purity now will now be mass of pure, which is 0.53. Now, then over mass of impure, which is 12 grams. 12, then times 100 over 1. So our answer will now be, now we have 0.53 times 100, then divided by 12. Answer is 4%. 4.4%. So if they now ask you, calculate percentage impurity, you can do this one in 2 ways. You can use the formula percentage impurity equals to mass equals to 100 minus percentage purity. So that gives us 100 minus 4.4, which gives us 100 minus 4.4. Answer is 95.6. percentage impurity is equal to mass of impure. Mass of impure mass of impurity, over mass of impure times 100 over 1. If you want to stretch yourself. Impurity means the dirty thing that is added to the pure substance that make it dirty. So to get the amount, the mass of that sand that is added, you subtract what? The pure from the impure given to you. Are we there? So we now have percentage impurity will now be 12 grams of impure minus what? Pure, 4.4 over mass of impure, which is 12 grams. This is an error. This is not, the mass of pure is what? 0.53. So we have 12 minus 3, 12 minus 0.53. Answer is 11.47 over 12 times 100. So this one now times 100 equals to this one divided by 12. It gives us the same answer, which is 95.5% that we got before, or 0.66%, which is the same thing as this. So these are the two ways you can do it. So we have come to the end of this lecture. If you have any question to ask, you can put it in the comment section, or you have any advice you want to give me to improve, you can please put it there. So and then help me to like this video, subscribe, share it so that others can benefit from it. And remember, I almost said, Afe Ademola Johnson. Thank you very much. God bless.